So let's do some more simplifying of radical expressions. Our strategy is going to be to continue to break these down as much as possible. So, for instance, on something that looks like this, my first thought is immediately to split this into 3 radicals to start. So I'm going to turn this into the cube root of 24 times the cube root of a to the 9th times the cube root of b to the 4th. This allows me to start thinking about this in smaller chunks. So I could tackle either or any of these radicals in whatever order I want to. I kind of like to work left to right, that's just sort of how I think. So to simplify my cube root of 24, I am going to do a factor tree. So this could be scratch work somewhere else. 24 is 4 times 6, and my 4 is 2 times 2, and my 6 is 2 times 3. So when I do my factor tree, I see that 24 is 2 to the 3rd times 3. And remember, I'm looking for groups of 3 because my index is 3. So when I come back over here, I can say, well, 24 is the cube root of 2 cubed times the cube root of 3. That's how my 24 breaks down. And then my a, I can leave it as the cube root of a to the 9th, or I could call that a to the 9th. That's a cubed times a cubed. That's really what's happening. That is not true. That is a cubed times a cubed times a cubed. That's a little bit better. This is the radical way of thinking of it. If you would like to think of it in terms of radicals, this is how you would think about it. And then my b to the 4th is going to be a b cubed times a b, because there should be 4 b's inside there. And I am, again, looking for groups that match my index. Let me actually just write that down here. We're looking for groups of the same size as the index, which for us in this case is 3. That's my strategy as I'm breaking things down. So the cube root of 2 cubed, these two cancel. Let me do that in a different color. Just do it here. These two cancel, which leaves me with a 2. But I can't do anything to that cube root of 3. There's only one 3. He has to stay inside the radical. But with this cube root of a cubed times a cubed times a cubed, I'm going to have 1, 2, 3 a's come out of that radical, because there are 3 groups of 3. Now, also, you could think of this as a to the 9 over 3, which is a cubed. Same answer, different thought process. And then for my b cubed, this piece will leave the radical, leaving me with a b, but this lonely b here has to stay inside the radical. So I have several different chunks here, and now we're going to write them together in a standard form. So I'm going to have my 2, and then my a cubed, and my b all outside the radical. And then with my index of 3, I'm going to write my 3, and then the b and the 3 are just multiplied by each other inside the radical. So you can just write them next to each other. And this would be the final simplified form for this problem. Let's look at another one. I would like to simplify the fourth root of 32z to the 7th. Once again, my basic strategy is to break this into pieces. So I'm looking at the fourth root of 32 times the fourth root of z to the 7th. And one more time, I'm going to write out the factor tree for 32. That's 4 times 8. That's 2 times 2. 4 times 2. 2 times 2. And when I look at all my 2's, I get a 2 to the 5th for that 32. So when I come over here, I have really the fourth root of 2 to the 5th times the fourth root, that needs to be an index, of z to the 7th. And when I'm looking at these numbers, I am trying to figure out how many times that 4 is going to go into that 5, how many times the index is going into the power. So I know that 4 goes into 5 one time with one piece left over. So I'm going to write out that thought process. This is 4. I have a 2 to the 4th times a 2 to the 1st. So this is my first 4 2's, and this is my last 2. Similar thought with the z's. I'm going to have a z to the 4th, and if I pull a z to the 4th out, I'm left with a z cubed, because together these make z to the 7th. And then the piece that has a power that matches the index leaves the radical. So this leaves me with a 2 times the fourth root of 2 times a z times the fourth root of a z to the 3rd power. Because that's how many z's could not leave the radical. This z cubed and this z cubed are the same. So our final answer, I'm going to put everything to the front that isn't in the radical. And then I've got the fourth root of everything that stays inside the radical. So that's my 2z cubed. As I'm looking at this, inside my radical, I don't have any powers that are bigger than my index. That is one indicator that I am simplified. So as you're going through here, make sure if this were a z to the 5th with a 4th index, I would have to continue simplifying it. But I essentially have reduced all of my fractions as far as my exponents are concerned, and that's how I know that I'm fully simplified. So to simplify this one, I'm going to, I think I want to break this into its numerator and denominator first. So I am going to have a square root of 80 times the square root of y over a 3 times the square root of 5. Now the 3 is already outside the radical, so I'm actually going to move that all the way to the front. That 1/3, there's a ninja 1 right out front. So this 3, I'm just going to pull it as a 1/3 all the way to the front. And what that will allow me to do is group my 80 and my 5 together under one radical. Because I'm allowed to push 2 radicals together if I want to. And then I'd still be left with my square root of y out front, or in the back. So now I can just look at 80 over y. And 80 over 80 over 5. 80 over 5 goes into 80 16 times. You may not know that, but Use your calculator. And now I know that the square root of 16 is 4. So I have a 1/3 times a 4 times the square root of y. And with a quick multiplication of my fractions, I wind up with a 4/3 times the square root of y, which, if you'd like to, you could write as 4 square roots of y all over 3. I think I'd like to do one more in this video, and then we will stop and do another video. So we are going to look at using the same strategies that we had before. I would like to bring my numbers together and my x's together under the same radical. So when I rewrite this, I'm going to bring the 5 all the way to the front. He'll just kind of hang out by himself. But I'm going to have the cube root of 162 over 3 times the cube root of x to the 8th over x to the 2nd power. So now I can do all of my division before I take my root. So this is 5 times the cube root of, and if I do a little bit of division in my head, let's see, 3 goes into 16 5 times, 3 goes into 12 4 times, I've got the cube root of 54. Use your calculator if you didn't follow what I did there. And then the cube root of, I'm going to be very explicit here, this is x to the 8 minus 2. Just remembering our rules of exponents. So I'll do my factor tree for 54, so you see where things are coming from. This is 2 times 27, which is 3 times 9, which is 3 times 3. So this is 3 to the 3rd power times 2. And again, I'm looking for my index here. My index was 3, so that's why I like that the 3's are grouped together like that. So I've got 5 times the cube root of 3 cubed times the cube root of 2. I split the 54 into those two pieces. And then I'm going to have a cube root of x to the 6th. When I simplify this, these two 3's will cancel. So I have a 5 times a 3 times the cube root of 2. And then the cube root of x to the 6th, I could think of it as x to the 6th over 3 if I'd like. And you guys might see that that automatically is an x to the 2nd power. So now I'm ready to write my final answer. I have a 15. So 5 times 3 is 15. These two pieces come here. I'm going to write this here as an x squared. And then my 3rd root of 2 gets tacked on at the end. The radical pieces are always going to go to the back. And that is the simplified version of this one. Alright, we will take a break, and then we will do some more of these on the next video.